Greetings of the day. I'm Shivani Tripathi and I'll be presenting Human. Cloud operators need reliable short-term workload forecasting for auto-scaling, deciding how many VMs or containers to allocate and when to scale. But real traces are challenging because they have long stable periods interrupted by sudden bursts and regime shifts. While deep transformers and large recurrent models can capture these patterns, they often introduce higher latency and compute cost, making them less suitable for CPU-only or cost-constrained deployments. To address this, we propose Human hybrid causal temporal dynamic neural router. The core idea is simple. Instead of using a fixed depth model for every input window, we adapt the computation depth dynamically. We work with a univariate workload series at 10-minute granularity and perform one step ahead prediction using a look back window of 24, that is 4 hours of history with standardization based on the training split. The key component is dynamic router. For each window, we compute four interpretable statistics that are mean, standard deviation, last value, and short horizon trend, and feed the 4D vector to a small MLP that outputs routing probabilities like alpha 0, alpha 1, and alpha 2. These probabilities control three paths. Path 0 is a shallow and fast for smooth segments. Path 1 uses hypertemporal causal block, and Path 2 uses the full stack for harder, more variable windows. Each HC block combines block sparse causal attention for efficient local temporal context and a localized GRU to react to recent burst, fused through a learned gate with residual connections for stability. The final prediction is weighted fusion of the three parts of output. We evaluated on chronological 60-20-20 splits and compared against load dynamics and WGAN GP transformer baseline. The results show that Human remains competitive and adaptive on Google 10-minute dataset, and Human performs close to the transformer baseline, and on the Azure dataset, Human achieves best MAPE of 29.52%, improving over both baselines. Overall, the takeaway is that adaptive routing with lightweight temporal statistics let us keep strong accuracy while staying compact and practical for CPU efficient cloud deployment. Thank you so much.